this video we are going to discuss about the domino gates. So on completion of this domino gates, students will be able to design the domino gates and to find out the difference between the domino and the dual rail domino gates. So first of all, when we see about the domino gates, this domino gates is a CMOS based evaluation of dynamic logic techniques which is based on both NMOS as well as PMOS transistor. So this domino gates is also a type of CMOS logic. Here we uses both a single pull down network and a clocked PMOS transistor as a pre-charge device. This pull down network is composed of NMOS transistors. So this NMOS transistor why we are using it for implementing the logic function, and also this domino logic is this will eliminate the NMOS glitch problems without introducing any PMOS type logic gates. The main thing is the basic of this gates will arise from the origin of the problem which is found at the NMOS cascade at the input of the inverter. So why we are using this dominoes means this is for playing the positional games. So if you are in the positional games, if each player in turns plays a domino edge to edge means then this adjacent phase will be found to be identical. So for that purpose we are using this one, and this domino logic is normally used in various stages, that is for example in evaluation stage, the next stage evaluation, then which is similar to the dominoes falling from one after another. So these are the cases we are using this domino things. So here you can find out the inputs and the outputs. So this inputs and outputs here we are using, which is very focused for changing the inputs to outputs, mainly for the transition from one problems to another. If any problems occur in the P side, these problems will be changed in the NMOS side. So for that 3 gates are being shown here, and also this domino gates if you see means the main problem will convert the outputs into the rising side than the next stage. So the dynamic static power, totally we call this as domino gate, because this pre-charge is mainly occurring or it is setting upon the chain of dominoes, and the evolution which is causing in the gates to fires, which we call it as single input. Mainly this clock output may pre-charge or it can be evaluated in all the stages. The major thing is the output is falling during the evaluation stage, and also it changes from lower to higher. So here this the things you can see in the circuits. For example, we can say the AND and the NOT gate. So in the NAND gate here we can see the static inverter is usually a high skew gate, so it can be raising from the rising output, and also the pre-charge may be occur on the parallel side, but the evaluation may occur sequentially. So the symbols of this dynamic inverter are shown here. So you can find out the given stage. Next you can compute the values from the static values to dynamic values. The major thing is first it will be pre-charge, and next it evaluate, again it goes to the pre-charge state. So there is a change from one pre-charge to other state. And the next one is domino rail domino gates with completion prediction. So here these gates are mainly used to pair the wires, the input and the output wires, where here we are denoting is just YI and YH. So this H wire is asserted to indicate the output of the stage, that is either it can be high or 1. The wire is asserted to indicate the output of the gate, and it is very low or 0. So when the gate is in the pre-charge, neither it is asserted or it can be simultaneously asserted with the operation. Main thing, this gates accepts both the true and the complementary inputs, and if that it can complete both the true and the complementary outputs. Both the inputs and outputs are connected to the pre-charge clock. And here therefore this dual rail domino can be viewed in the dynamic form also, which we call it as DCVS. So the major thing, this loses the efficiency in the case of wider dynamic NOR gates, and it can require more complementary dynamic NAND stops, which is not the result of real computation. When this computation completes, we can find out the assertion of the AND gate as well as OR gate. Quiz questions on domino gates. How to design domino rail domino gates? Thank you.